So energy of waves. Make sure you copy this on the right side and on the left side on a new section in your notes. So all waves travel at the speed of light, which we've already covered how fast the speed of light is. It's really, really fast. 3 times 10 to the 8 meters per second. Now the following formula is used to calculate the wavelength and the frequency. So remember, the wavelength is how big the wave is. The frequency is how many waves there are, like 1, 2, 3. That frequency right there would be 3. How many of those are there? Now, determining on the wavelength and the frequency, just like with sound, we can determine what type of energy this is. Is this an X-ray? Is this a infrared? Is it ultraviolet? So anytime that we're trying to measure what type, like how far stars are and planets and all that stuff, how do they know how far a star or a planet is and all that stuff? It's with these formulas, like this one right here. We can tell how far away something is with this, okay? So C is always going to be the speed of light, 3 times 10 to the 8. The frequency, they're going to give it to you in hertz, Hz. And wavelength, it'll say this is the wavelength, and it'll usually be in like meters or so on. So microwaves are used to transmit information. What is the wavelength of a microwave having a frequency of 3.44 times 10 to the 9? So the speed of light is always going to be given. You should always know the speed of light is that, okay? Now, frequency, they're telling you here the frequency is this. And we're supposed to solve for wavelength, which is this, looks like an upside down Y thing. So that's what we're solving. Now, what I like to do is make sure that all of that is together, right? Now, to solve for this, we've done stuff like this before, okay? When we were trying to do like the gravitational attraction stuff, where we had these big, huge, giant numbers or small numbers. So we're going to do the same thing here. I'm going to take this whole thing. This cancels. And we're left with that. Okay, so now we're going to do 8 times 10 to the 8 divided by 3.44 times 10 to the 9. Now, if you remember how to solve these problems, they are not hard problems to solve. Okay? This stuff right here, I'm going to do that first. 8 divided by 3.44. 8 divided by 3.44 gives me 2.32. And the exponents, if we are dividing exponents, we're going to subtract them. So 8 minus 9. And that's my answer. Okay. So exponents, we are subtracting. We're just doing the same thing that we did the last 9 weeks. Let's do another example. Copy this on the right side, okay? So Planck's constant. What is Planck's constant? In a way, Planck's constant is supposed to be the absolute tiniest measurement that we have. So if you want to measure a table, you can do it like in feet or centimeters. You can measure things in meters, right? But how do you measure energy? Well, the unit to measure energy is supposed to be, it's this, okay? This is the number that, picture a ruler and it says meters and centimeters and millimeters, and it starts getting tinier and tinier and tinier. This is supposed to be Planck's constant. So Planck discovered that every time he multiplied the energy of a light particle, okay, a photon is a light particle, and he measured its wavelength, and he divided it by the speed of light, he always got this measurement. Okay? So this number is going to be a constant that we're going to be using over and over and over again. So it's the tiniest form. So it's kind of like, again, when we measure how tall someone is here in the United States, and they say, how tall are you? Oh, I'm 5 feet 5 inches. I'm 6 feet tall, right? That's the standard. It's feet and inches for measuring somebody's height. If you want to measure energy, you're going to be using this, okay? And this stuff, we can, again, figure out what type of radiations it is. Is it a radio wave? Is it a microwave? And all that stuff. And if you think about it, all that stuff is important. Whenever you get sick and you have to go to the doctor and they do like all these tests, they do like MRIs and all that stuff, they're using a form of radiation or another. When you go to the dentist, they're using X-rays, they're using all this stuff, okay? So this is the number that we're going to be using, okay? So you don't have to worry about the formula here. It's just this little explanation. So this is the number that we're using to measure energy, okay? So copy this on the right side and on the left side. So once we know the wavelength and the frequency, we can find how much energy that specific light or electromagnetic wave or radio wave or microwave has using the following formula. So we can tell what type of like energy it is. So energy equals Planck's constant times frequency, or we can use this other formula, which is Planck's constant times the speed of light divided by wavelength. Okay, so in this example here on the bottom, tiny water drops in the air disperse the white light of the sun into a rainbow. What is the energy of a photon? Again, a photon is just a little light particle from the violet portion of the rainbow if it has a frequency of 7.23 times 10 to the 14 hertz. Now, I know this stuff seems really complicated and oh my gosh, Planck's constant, frequency, speed of light. As long as you plug in the stuff in the correct area, you will be fine. Okay, so we're going to use one of these two formulas. So how do we know which formula to use? Well, let's look at the number that they're giving us. They're giving us this number and it says frequency. So anytime you see the word energy, we're going to have to use one of these two formulas. Okay? So now they're giving you frequency. So which formula has frequency, the top one or the bottom one? And it's the top one, right? You can see right there, frequency, right? This bottom one, it has wavelength. Okay? So we're not going to use this one. We're going to use this top one. So Planck's constant times the frequency. So here, let me write down the frequency, 7.23 times 10 to the 14. And you know what? Let's put that in parentheses. And we need to write Planck's constant. So Planck's constant is 6.62 to the negative 34. 6.62 to the negative 34. Now, how do I solve this? Well, it's no big deal, right? What color should we use? Purple. This right here and this right here, I'm going to multiply those because this whole thing is telling me to multiply it by this, right? 6.62 times 7.23. 7.23. Wait a minute. Times 7.23. 47.8. Okay. And whenever we're multiplying exponents, so remember here in this problem, when we divide exponents, we subtract them. When we multiply exponents, we add them, right? So negative 34 plus 14. -34 plus 14. That gives me -20. Now, there's a problem here. The problem is the decimal is in the wrong spot. We have to have it in correct scientific notation, right? So here, let's do a quick little number line. 0, 1, 2, 3. Over here we have -1, -2, all the way up to -20, right? -3, -4, all the way up to -20. So since I moved the decimal over to the left, I was at 20, and I moved it over to the next number, which is -19, right? -19, and that's my answer. Okay. Okay, let's do another example. So all of this is going to go on the left side of your notes. You're going to have to leave some space here. So how do you know when to use each formula? We have 3 formulas now. There's 3 formulas. And instead of writing energy equals Planck's constant times frequency, this is the symbols that we use. Okay? For energy is E, Planck's constant is H, and frequency is F. Okay? This formula right here, Planck's constant we said was H, speed of light is C, and wavelength is this upside down Y looking thing. It's a Greek letter. Okay? And here we have the speed of light. C equals F times wavelength. Okay, so these are, it's a lot easier to kind of see these tiny formulas and to write them all out. So knowing when to use each formula, every time a question has energy in it, whenever you see a question and it says energy just anywhere on it, we're going to use one of these 2 formulas. Okay? If the problem does not say energy at all, we're going to use the speed of light formula. And of course, H is always Planck's constant, the 6.62 to the -34. C is always the speed of light, and so on. So here, let me give you an example. What is the frequency of green light, which has a wavelength of 4.90 times 10 to the -7? Now, which formula out of these 3 are we going to use? Well, the first thing you want to do is you're looking for the keyword energy. That's your keyword and doing these problems. Anywhere on here, do we see the word energy? And we do not. We do not see the word energy, so that eliminates these 2 formulas. Therefore, we're going to use this formula. Okay. So here, let me go ahead and, since I already wrote this, it's the speed of light. They're giving me wavelength, which is this one. So we're looking for frequency. And the wavelength is 4.90 times 10 to the -7. That's all together. So we're going to put that in parentheses. So 4.90 times 10 to the -7. 4.90 times 10 to the -7. This cancels. Let's see if I can write that better. It should be a 9. Okay, so in solving these, don't get scared. Do the same thing, right? Let's take care of this right here. 3 divided by 4.90. And I get 0.61. The exponents, we're going to subtract them. 8 minus -7. 8 minus, and we have a -7, so we're doing that, right? As long as you put everything in the calculator in the correct order, you will be fine. 8 minus 7, and don't forget the negative sign, and I get 15. Okay. This decimal is in the wrong spot. It should be right there. So let's see where we were at. That's 0. We were at 15. 1, 2, -1, -2. So 15, we moved it over once there. So we moved it this way, so the next number would be 14. 14. Okay. And since this is frequency, the units for frequency are hertz. Okay, so now let's look at the next problem. What is the energy when given a frequency of 6.32? Remember, the keyword that you're looking for is energy, and there we see it, energy. So now we have between the top formula or the bottom formula. So now let's look for the next thing. It's giving us frequency. So out of these two formulas, which one has frequency? And it's this one. Okay. So E equals HF. So H is always 6.62 times 10 to the negative 34. So where am I getting that from again? That is Planck's constant. See, H is 6.62 to the negative 34. Okay, it's right there. And they are giving us the frequency. Right, so this is a formula, E equals HF. H is that, frequency is that. Now we do the simple task of putting this in the calculator. I'm going to multiply these numbers that I have underlined. $41.8. And the exponents, since we're multiplying, we add exponents. Negative 34 plus 20, negative 14. These big numbers, when I was in high school, they used to scare me, and even in college. And once I found out that it's not so bad, you multiply the numbers, you add the exponents. Oh my gosh, how easy is that, right? They're not that bad. It's just that you're not seeing numbers like this, but you get used to it and it becomes easy, right? So the decimal is in the wrong spot, 4.18. So let's do our number line, 0. So we are this way, right? We are in negative 14. We're all the way in negative 14. And I moved it from here to this way. I moved it to the left. So what's the number going to the left from negative 14? Should be negative 13. Okay. There we go. We're going to do a couple more examples because I know this is a little, well, not strange, but it's new, right? It's new material. So I don't expect you guys to be experts, and you're never going to be an expert in anything that is new to you. So the only way to do that is to practice. So go ahead and copy this on the left side. You might have to do on another section on your notes. But as you guys are copying this down, energy is our keyword. That's the first thing you want to look for, that word, okay? If you have that word, it's going to be one of these two. If not, it's going to be this one. If you see energy, then you're going to have to decide which formula to use from here. So let's look at the first one. What is the energy? There it is. So it's going to be one of these two formulas when given a frequency of that. So out of these two formulas, which one has frequency? The first one. So this is my formula, E equals H times F. I'm going to space these out because these numbers start getting kind of big. H, 6.62 to the negative 34. They're giving me the frequency, 9.50 times 10 to the 13. And now we multiply. I'm going to multiply just those numbers. 6.62 times 9.50, and that gives me 62.89. The exponents we're multiplying here, so we're going to add them. Negative 34 plus 13. Right, let me write that down. Negative 34 plus 13. So where am I getting these from? From right here. 34, 13, right? Negative 34 plus 13. Negative 34 plus 13 gives me negative 21. Now that decimal is in the wrong spot. So, number line. 1, 2, these are positive numbers, these are negative numbers. So we're all the way up to negative 21. Negative 21. And I went to the left, so the next number from negative 21 would be negative 20. And that's my answer. Okay. I'm going to have to erase these, all of this, every time I do a problem because it starts getting jumbled up. Okay. So let me erase this as I start my next problem. So here, remember, we're looking for the word energy first. Okay, that's the first thing you do. Anywhere around here, do we see the word energy? We do not. So that eliminates these two formulas. So we're going to use this formula. C equals F times wavelength. And C is always this number. That's the speed of light, 3 times 10 to the 8. And we wrote that down. Okay, we wrote that down here. Speed of light is 3 times 10 to the 8. Okay, C is speed of light. So that goes there. They're giving us the wavelength. This is right here, wavelength of that. So that goes here, 1.15 times 10 to the negative 10. And we're solving for F. So how do we solve for F? By dividing. Moving that whole thing over. So this whole thing cancels. And now I am going to divide that. 3 divided by 1.15, 2.6. Since we are dividing the exponents, we are going to subtract them. So here it's 8, and negative 10. So 8 minus negative 10, right? That's this part, 8 and negative 10. 8 minus negative 10. 8 minus 10. And that gives me 18. This problem looks really tiny, right? I mean, yeah, the numbers look expanded, but it's small. I mean, it's nothing to it. I'm going to erase this so that I can do the next one. So remember, we're looking for the word energy. Do we see the word energy? And we do not. Therefore, we're going to use the same formula. Okay. C is the speed of light. And remember, if you ever forget anything, it's right here, right? So it's 3 times 10 to the 8. This is 3. That 8 was in the wrong spot. Equals, they're giving me the frequency. And we're solving for wavelength. Okay, so let's divide that whole thing. Divided by 7.8 times 10 to the 6. This whole thing cancels. So we are left with 3 times 10 to the 8 divided by 7.8 times 10 to the 6. So let's do that. 3 divided by 7.8. 0.38. I'm going to put the answer over here, 0.38. The exponents, we are subtracting 8 minus 6. There you go. And we have to move the decimal in the right spot. So number line 0, 1, 2. So we are at 2. Okay, we're there. And we move the decimal over. So the next number over is 1. And this is meters. Since it was wavelength. Okay. All right. So we're going to do a quick little, you don't have to copy this down. Just check this out. We're going to do this as fast as we can. They seem like hard problems, but they are not. Okay. So let's determine which formula to use here. Anywhere on here do we see the word energy? We do. There it is. It's one of these two formulas. So now we look at the next word, wavelength. Okay, wavelength. So which one of these two formulas has wavelength? And it's this second one. So this is the formula that we would be using for this problem. And from here we just plug in the numbers, right? H, 6.62 times 10 to the negative 34. H is that. C is the speed of light. And they're giving me the wavelength. The wavelength 1.18 times 10 to the negative 8, right? And from here we would solve this and we would get our answer, right? Okay, let's move on to the next one. We see the word energy there, okay? We're going to use one of these two formulas. So the next word that we see is frequency. So which one of these two formulas would we use? Which one has frequency? This one, right? Oh, and this is a good one. They're giving you the energy, 2.93 times 10 to the negative 25 equals, let's see. Oh, you know what? I think this problem should say, I remember I changed this problem. This one should say wavelength. So we would not use this formula, we would use this one, okay? The reason being is if we plug this in, then we would have H. And no, wait, no, I think it is. I think I did have it right. Let me go back. Oh, no, I had it right. Yeah, we are using this one. Okay, so they're giving me that. And H is Planck's constant. Let me erase that other part there. Let's make room. And then we would solve for F, right? So we would do the same thing. We would divide, and then we would kind of go from there, right? Divide. Divide. That cancels, and then we would solve it normally, right? Okay, let's look at the next one. We see the word energy. It's one of these two formulas. The next word that they give us is wavelength. So out of these two, which one has wavelength? And it's this second one, EHC, over that. So we plug in all the stuff that we know. Here they're giving you energy, so they're actually giving you this part. They're giving you that one. Okay. Oh, and I notice on my other problems, I should have been putting the units. Okay, the units for energy are joules. Obviously, we went over that the second 9 weeks. So all those problems, they should have a J for joules. Okay, so energy. Anyway, let's look at this problem again. We are using this formula. They are giving us the energy, so that goes there. H is always 6.62 times 10 to the negative 34. C is the speed of light, 3 times 10 to the 8. And you know what? Hold on. If you guys had room in your paper, that's great. Let me make room here so that it all fits nicely, or somewhat nicely. 6.62 times 10 to the 34, negative 34, and C is the speed of light. And then we're solving for wavelength. So how would we do that? Same way, cross multiply, and you multiply all the numbers and you kind of go from there, okay? All right, so I'm just showing you which formulas we are using. The math part shouldn't be too much of a trouble, but it's doable, okay? Let's look at another one. What is the wavelength of the electromagnetic radiation having a frequency of this? So anywhere on here, do we see the word energy? We do not. Therefore, we're going to use this formula, right? C is always, I don't know why I'm putting 8 first. It's 3 times 10 to the 8. They're giving us the frequency. And we're solving for wavelength, right? And then from here, it's just doing the simple stuff, right? Dividing, multiplying, doing all that good stuff, right? And then here we would divide, we would subtract the exponents and so on. So that's how you solve these problems. How do you know which formula to use? If it says energy on it, it's one of these two. Then you look for either frequency or wavelength, and it's going to be one or the other. If you don't see energy, then you're going to default to this formula, okay? And all these formulas are meant to help us understand what type of radiation is given off. Is it a microwave, an X-ray, and so on. We can use this to help us with types of radiations that are given off in experiments that are being done. We've used all of this for health reasons. If you go and you get like an MRI, an X-ray, and so on, we know the dosages that you can give and how much of this energy is going to be lethal. We've used this as well to test out how far away stars are, what kind of radiation are they giving, and so on, okay? But there you go. That's how you do this part of the lesson.